Well, I don't know. Do you think maybe we should get started? It is after a minute or so after the hour.
Sure. Or I will get started then. So, well, hello everybody. Good afternoon. Welcome to the third satellite application virtual training for students that organized by the AMS Satellite Meteorology, Oceanography, and the Climatology Committee. And many of the committee members are here, and I'm going to list their names in the chat, but you can also see them on the AMS website. And today, as I said, is the third session for the training this summer. And the last one, the first one will be in August, August 11th. And today, we're very lucky and also very happy to invite Cara Wilson from Noaa Environmental Research Division to give us a talk and give us a training on satellite applications for fisheries. And Cara is a senior satellite oceanographer in the Noaa Southwest Fisheries Science Center in Monterey, California. And he is the lead for two regional nodes of Noaa's Coastal Watch programs. One is in the West Coast region, and another one is in the Polar region. So it's good to have you, Cara. With that, I turn everything back to you then.
Great, thank you. Thank you, John. Well, I'm pleased to be here today and talk to you about oceanographic satellite data sets, which is my specialty. We are going to be talking today about examining marine heat waves, and we're going to use heat waves as a case study to demonstrate Erdapp. If you went to the first session 2 months ago, Scott talked a little bit about Erdapp when he gave a review of sort of a bunch of different tools that you can use. And Erdapp is a gateway to access to hundreds, thousands of data sets. Primarily, it's used a lot in the oceanographic community. I don't think it's used that much in the meteorological community. But if you're interested in oceanographic data sets, Erdapp is definitely something you want to know how to use. And so that's what I'll be showing you today. As John mentioned, I'm at the Southwest Fisheries Science Center in Monterey, California. My co-authors are Andrew Lysing, who's at my same lab as well. And he's actually sort of one of the experts on marine heat waves. And he gave me all the slides I'll be showing you today on marine heat waves. And then Dale Robinson works with me at the NOAA's Coast Watch, the West Coast node. And I'll be talking about Coast Watch as well, which is basically a part of NOAA that distributes oceanographic satellite data. So to get started with some logistics, as we've done in the other sessions, we're going to use Slido for poll questions and for questions and answers. So please, if you have any questions and answers, and it looks like we're a pretty small group here, I really encourage people to ask questions. And if you do that, to please do it during Slido. It makes it easier if we have it in one place. So it's a little bit more confusing if you do it in the Zoom chat and in Slido. So please ask any questions in Slido. For my co-host, as you know, if I'm presenting, I can't actually see the questions in Slido. So certainly, if there are questions in there that seem relevant, please stop me and so I can explain things before if people are confused. This session is being recorded, so if you have an issue with that, just to let you know, it is being recorded. So let's start off with some Slido questions. And so I will escape out of my PowerPoint and go back into Slido. And so to go to Slido, it's just slido.com. And then it's SatMOC training -3. And so I have Slido open. So the first question is, there were 2 homework assignments that I gave you to do before this. And did you watch the satellite data video? And how do I see?
It'll take them a minute to enter in the code.
Okay. And so, keep in mind, this is not, we don't know who you are, who said yes or no. So be honest, I just kind of want to get an idea of who saw that material and who didn't. So I know where you're all at. What do I do then, Bill, to see the results? Bill? So, okay, great. So it looks like everybody watched the video. Great. And I guess if you had any questions about anything that you saw in there, you know, certainly put it in the question and answer. I can get to it now, or we can come back to it. So then the second part of the homework assignment was to, if you looked at the online Erdapp tutorial. Can you pull that question up, Bill?
All right, hold on.
Okay.
Why don't you continue on? I'm having trouble sliding.
Okay. All right. Then we will move on then. So let me go back to the PowerPoint. So I had some more Slido questions, but I guess we'll just skip them for now. Okay, so as I said, there's going to be sort of two parts to this presentation. First, I'm going to talk about marine heat waves. I'm going to talk about, you know, what is a marine heat wave? Why do we care about what marine heat waves are, what they do? And then in the second part, I'm going to introduce Erdapp and talk about what Erdapp is. And then we're going to use Erdapp to visualize marine heat waves. And as I said, this is just sort of like a case study to show you what Erdapp can do. Once you understand how to use Erdapp, it really opens up a whole suite of satellite data and other in situ data sets that are available to you. So it's a really great resource to be familiar with. So we had a Slido question, but I guess Slido is not working, so I'll just kind of, it is?
Slido is back. Yeah.
Slido is working? Okay, great. Let's go back over to Slido then. Who viewed the online tutorial on Erdapp? Well, I did because I made it. Looks like most people did. That's great. Okay. What do you want to get out of the session? That's my answer. Nobody else has any answers? Knowledge and experience, great. How to create charts, utilizing data, learning how to use Erdapp. Any more comments? All of the above, great, cool. The next question, Bill, was, yes, so you all said that you looked at the video, so here's your test on that. Name 4 oceanographic measurements that are made from satellites. And of course, I'm not going to answer any because I want you all to do that. Sea surface temperature, sea surface salinity, ocean color, or sea surface height. Exactly, those were the parameters I was looking for. SST, sea surface height, wind vectors, sea ice, very good. Yeah, that's basically it in a nutshell. So let's move on to the next question, which was about the blob, I believe. So have you heard of marine heat waves or the blob? Great. Most people have. Oh, no. It's about 50-50. Okay. Interesting. I guess, actually what I should have asked, I didn't put this question into Slido, but I'm curious how many of you are sort of more meteorological or oceanographic, because obviously the marine heat waves is something that's a pretty well-known phenomena in the oceanographic community, but maybe if you're coming from the meteorological community, you might not be so familiar with it. So that's a good place to start off then and talk about the marine heat wave and the blob. So let me go back to my PowerPoint. So the blob, the blob was the first name that was given to this phenomena, this oceanographic phenomena that basically developed in 2014. And basically what it was is just this blob of really warm water that was situated in the Pacific Ocean. It looked like a blob, and we'll see it later. Obviously, the blob is not a very scientific name, and so marine heat wave is the sort of more scientific, technical term that has been used for these events, and there have been other events as well. They've gotten a lot of attention. You can see here from the cartoons. Presumably everybody's heard of the El Nino, which is a phenomena which we have in the Pacific, where we get warm waters. There's a different pattern that we get with El Nino and with the blob, but as you can see from the cartoons here, they're sort of similar creatures, and that's been depicted in the media as well. So what these images are showing here are they were articles that were talking about the blob's impact on ecosystems and sort of the disastrous impacts it's had. And so you can sort of see that from the cartoons, where there's sort of havoc and destruction being wreaked by these things. So that's what a marine heat wave and the blob is. So in terms of what is a marine heat wave, here we're seeing an image of SST in the background. So you can see that really this very red water here, this sort of in a blob-like fashion. That's basically a visual representation of where the warm water is, the blob or the marine heat wave. There have been times when there's actually been sort of two areas, and so you can see that here in this image, there's this large area over the Pacific here, just off the west coast, and then there's actually another one here over Alaska. So there's different ways that they are represented. Sometimes it's sort of one feature, sometimes it's two, and then sometimes it's not there. So that's sort of visually what it looks like. But as scientists, we always want to have an actual definition. And so how it's been defined is any time and place when the ocean temperature is greater than some threshold for at least 5 days in a row. So what do we mean by a threshold? We define a threshold based on past history of ocean temperature at that spot. So basically, if we have what we call a climatology, if we have years and years of data, which we do, our records of sea surface temperature go back to 1985, then we know at any spot what is the average temperature. So, if it's warmer or colder on that day, we can make an anomaly. And so basically, these are areas where the anomaly is very large compared to the normal climatology. In practice, we basically consider a spot to be in a heat wave if the temperature is warmer than 90% of the measurements ever taken at that spot. So it's really, these are temperatures that are really quite outside the standard deviation of variability for an area. So to show you kind of what that looks like, what we're looking at here is a time series for 2 years of data from one spot in the ocean. I don't know exactly what spot it is, but it doesn't really matter. The blue line is the climatology. So that's the average temperature in that area. And you can see there's a really large seasonal signal here. And then the green line on top of that the black line on top of that is the actual sea surface temperature. And you can see that it's above the climatology for almost this entire time period. The green line is the threshold. So that's the threshold for what we, if it's above that temperature, we're going to classify it as a marine heat wave. And so colored in red are the time periods in this spot when we have a marine heat wave going on in this area. So this is just showing it. The difference between the climatology and the actual temperature is the anomaly. So that's basically the whole area between the blue and the black. But just that red area is the area above the 90% threshold. So that green line, the difference between the green line and the blue line, so which is basically anything above that we're going to call a marine heat wave, is translates to about 2-degree anomaly. So basically, if the sea surface temperature anomalies are greater than about 2 degrees, then it's going to be what we're going to classify as a marine heat wave. So there were a lot of impacts of the marine heat wave. The first big one was between 2013 and 2015. Here are just some sort of visual impacts of what happened. You can see there's some really, we had dead seabirds. The sunfish, the mola mola over here is really quite skinny looking. They're usually really puffed out. You can see how kind of wrinkled and skinny it is. You can see this emaciated sea lion here, a lot of strandings of different things on beaches. So there were the very wide range impacts on the ecosystem of these marine heat waves. Just to sort of give you this in a little bit more detail, we saw decreases in phytoplankton. There was a lot of movement of different fish and marine resources in the ocean. So tuna were caught a lot further north. There was basically a lot of changes in the distribution of populations in the ocean. A really good paper on this is Bond et al., the causes and impacts of the, oops, typo there, 2014, not 2104, warm anomaly in the Northeast Pacific. So if you're interested in this, this would probably be this paper would be a good place to start on the impacts of these marine heat waves. Not everything was negatively impacted by these heat waves. There were some populations that actually benefited from this. So toxic phytoplankton, what we call harmful algal blooms, we actually saw a lot more harmful algal blooms. So if you're one of those phytoplanktons, that was a good thing for you. wasn't good for those populations that are negatively impacted by harmful algal blooms, though. A lot of the tropical and subtropical copepods had northward range expansion, so there's basically more warm water, so they were happy about that. Squid and rockfish and tuna had increased abundances because they had basically better prey, or the prey moving into their environment. So there was winners and losers. But okay, so now that we sort of know why they're important, how do we monitor and visualize marine heat waves? And to do that, we're going to talk a little bit, segue a little bit and talk about Noaa Coast Watch. Noaa Coast Watch is a national program funded by NESDIS. NESDIS is the National Environmental Satellite Data and Information Service. It's part of NOAA. And the Coast Watch program the mission is to provide access to and promote the use of ocean satellite data products. So clearly we're going to use satellite data to look at the marine heat waves, and we're going to be using data that we're getting from Coast Watch. As June mentioned in the introduction to this, there are the West Coast node and the Polar Watch node are housed at Southwest Fisheries Science Center. I'm the PI for both of those nodes. And so we serve up a lot of satellite data globally, also for the coastal regions, and the Polar Watch serves satellite data for the polar regions. And one of the main data servers that Coast Watch uses is Erdapp. So this segues into the second part of our talk about Erdapp and using Erdapp to access Noaa Coast Watch data. So we're going to go to Slido and ask people what your experience is with Erdapp. Let me go. Oh, did we miss a question, Bill, on the Erdapp? I thought this question was going to come later about SST measurements. Well, the question is here, so I guess we'll...
We must have missed it. I'll pull it up and we can cover it later.
Okay. No questions. So everything I've been saying is making complete sense. That's great. If you do have any questions, don't be shy. Put in the question and answer. As Bill is trying to get back to the question about Erdapp. So Jean or Gary, are there not any questions that have been put in the Zoom chat?
No, everybody.
Okay.
is happy.
Okay. Okay. So the question is, what is your experience with Erdapp? If you've never heard of it, if you've looked at it once or twice and couldn't make any sense of it, if you're somewhat familiar with it, or if you love it. So yeah, I'm not surprised that most people have never heard of it. As I said, it's used a lot in oceanographic community, but even within the oceanographic community, there's a lot of people who've actually aren't familiar with it. So we will be talking about Erdapp, and hopefully at the end of this, you'll become converts of Erdapp data. So let's get back into it, and I will explain what Erdapp is. And really, if you do have any questions, as I'm getting into this, please don't be shy. I think you're probably muted, but you could unmute your. Can people unmute themselves, Jun? Because I'm fine to be interrupted. So if you have questions, please ask them. Let me go back to my PowerPoint. Okay, so at least in the oceanographic community, there's a lot of different data servers. There's a lot of different places you can get data. The list on the left is an incomplete list of all the various places you can get satellite data. Some of these places are, have just one type of satellite data, like the NASA Ocean Biology just has ocean color. Sometimes they have just physical oceanography, like on the NASA JPL site. So sometimes you have to go to different places. Everything has different formats, different ways of downloading. Maybe you can subset data, maybe you can't. Maybe you can look at it first, maybe you can't. So it can be very confusing. And Erdapp was developed to try to mitigate these confusions and make it easier. So the whole idea of Erdapp is to make data access easier. It was developed at my lab by Bob Simons at the Southwest Fisheries Science Center lab. And how it works is it serves as a middleman. So Erdapp can get data that's served locally. It can get data from remote servers. And it allows users to access this in a number of different ways. It lets you subset data both temporally and spatially. You can download data in about 30 different formats, and that includes graphics and also data. But the key thing about Erdapp is that the entire data request is defined by a URL. So what that means is that you can write a URL that will either download data, a netcdf file or a CSV file, or can download a graphic. And that makes it really easy to directly access Erdapp through software, through like, say, MATLAB or R or Python. Makes it really easy to generate automatic scripts for computers to talk to Erdapp. So it's very powerful. It's a very powerful way of getting data. And on the Erdapp at the Noaa ERD at Southwest Fisheries Science Center, we have about 1,000 satellite data sets on our Erdapp. So once you understand how to use Erdapp, there's 1,000 satellite data sets that you can access. We have chlorophyll data, primary productivity, SST anomaly, sea surface salinity, sea surface height and anomaly, surface winds, etc. Most of these we have in daily, weekly, and monthly composites. And I should mention in the video that you all watched, the narrated presentation, we talked about the different levels of product. All of the data on Erdapp is what we call level 3 or level 4 product. So we don't have any level 2 satellite data, which is basically the data in the swath coordinates. All of our data has been gridded. You can also have non-gridded data on Erdapp, and we have a lot of non-satellite data sets, in situ measurements like data from gliders, from buoys, from field sampling programs, underway data. So this is data that we get from Noaa vessels and research vessels. We have a lot of model data and climatology data. So there's really a whole wealth of data that you can get from Erdapp. This is the Erdapp interface, and we say it's functionally beautiful. You might be thinking, yeah, beauty is, you know, individually defined, or maybe it doesn't look beautiful to you. We realize it can be very confusing, and you might look at this and make, you know, it doesn't make any sense to you. So let's walk through it. What we're looking at in the middle here is the dataset title, and we try to make these as explanatory and self-intuitive, you know, as self-intuitive as possible. So you can see here we have Aquarius sea surface salinity. It's level 3. It tells you what version it is, because sometimes there's different versions of data sets. It tells you the resolution. It's at a 1 degree resolution. It's a global data set, and it tells you the time period of this data set. And then lastly, it tells you the temporal compositing. So this data set's available in daily, 7-day, 3 months, or monthly. So we generally try to have all that information in the data set title. You can get metadata about the data set. That's if you go to the M column over here. There's more background information if you want to get more information about the data set. It's there. We consolidate data from a lot of different institutions. So it tells you quite clearly here what institution actually made that data. So in this case, it was from NASA Goddard. And then there's the data set ID, and that's a really important thing that you'll want to know, and we're going to come back to that later, and I'll show you how that comes into play in terms of it being important for you. And then for every data set, there's 2 things you can basically do. You can graph it. So if you go to the column over here where it says graph, and if you hit on that, it'll bring up an online interface where you can graph that data, and you can make changes to the graph. If you know you just want some of that data, you can go to the data column over here and just download the data. So, and there's also a search capability. If you were to click on Erdapp, there's a way that you can actually search. So if you're just interested in salinity or sea surface temperature, you can search for that, and you would get back those data sets that just have that keyword in your in the title. So this is the online interface to create custom graphs. There's a number of things you can do here. The graph type, which we're looking at here, this indicates the default is surface. So what that is showing you is a map. So we have here a map of sea surface temperature, but you could also change that to be a time series. And what that would get you is a time series. You'd have to select one point, but basically any point on here. If there's a point in the ocean that you want to sort of see what the sea surface temperature looked like over time, you could pick that and then indicate that the time scale you wanted, and you could get a time series at any point. You can get a Hofmeiler. A Hofmeiler is a term that's used in oceanography a lot, and actually we're going to make one later. But it's a hybrid map. It's a really cool thing. I'll show it to you later, where you basically have latitude or longitude on one axis and time on the other. So it allows you to see both temporal and spatial changes at the same time. As I said, I'll show you one later, and you'll see the benefit of that. And then you can also display vectors. So if we have vector data sets like wind, it'll actually display the vectors of that data set. The color here, what this is this is the color, the variable that's being colored here. Some data sets have more than one variable in them. And so by choosing which one is displayed here on the colors of the map. So in this case, we're looking at the sea surface temperature from this data set. The scale can be either linear or log. Down here for our ocean for chlorophyll data sets, we usually like to put those on a log scale because the variation is so large in the values that we get. There's about 40 different color palettes you can choose from, which is down here in the color bar. And then, as I mentioned before, the file type. There's over 40 different file types, file formats that you can display. And actually on here, this gives you a list. This is a partial list of some of the file formats you can get. What we're looking at now is this is the online interface to download data. So if you've decided you're interested in some data and you want to actually go and get it, you click on the data access form, and then here you can subset the data by time, by latitude or longitude. Here you can see there's actually 3 different variables in this data set, so you can pick the one you want. You could pick all of them if you wanted. This one had sea surface temperature, mask, and then a sea surface temperature anomaly. So in this case, we're just selecting one variable. And then this is showing you all the different files you can get it in. So you can download it in a MATLAB file, in a NetCDF file. If you downloaded it into a PNG, that would give you an image. And this will be a little bit more apparent, I think, when we actually show you when I do a demo of it, which I'll be doing shortly. So the key thing about Erdapp is that, as I said, the entire data request is put into a URL. So what we have here is an example of one. So the text going around the box here is showing you a very long URL. And what we've done here is we've broken it down into the different components of a request. So for the first part here, what we call the base URL, https coastwatch.pfeg.noaa.gov/erdapp/griddap. This is telling you basically which Erdapp you want to request the data from. There's about 85 different Erdapps out there now. This is the one that's the original one, the one that was first developed at our lab at ERD. And then after the Erdapp, the GridDApp, this is a gridded data set. We have gridded data and table data, but in this case, we're getting a gridded data set. In red is the data set ID. So that was what I was showing you on the first graph of Erdapp, where I said this is the data set ID. This is basically telling it which of those data sets do you want. And so every data set ID has a unique ID identifier. So this is a Noaa DHW, it's degree heating week, monthly. This is basically an SST. We're going to be getting an SST data set. The file type is, as the name implies, what kind of file do you want? In this case, we're getting a large PNG, so this is an image type. So this URL is going to bring back an image. But if instead, if we swapped out for a large PNG here, .mat, what it would do is it would download us a file in MATLAB format of the data that we are requesting. So it makes it really very powerful. Everything after the question mark is where the data request begins. Some data sets have more than one variable. If they just have one variable, they still have to name the variable. So in this case, the variable name is sea surface temperature. So that's what we're asking for. And then there's a time range and a latitude and a longitude range. So while this URL looks very long and very complicated, you can read this URL and understand what it means. It's just like learning a foreign language, right? You can, once you understand how it works, you understand it. So I can read this URL and know that what it's going to provide me is a PNG, an image file of sea surface temperature for June of 2021 at this latitude range and longitude range, which is in the North Pacific. Down here, I have the whole URL written out. And so when I click on that, it's going to bring up that image. So there it is. As I said, it's an image of sea surface temperature. And actually, if I make this a little smaller, and I'll make it smaller by going directly to the URL. So that's what I'm doing up here. And I had it pull up a large PNG. I'm just going to have it actually do a smaller one, so it's a little bit easier to look at. So all I'm doing is changing the URL. Now I have a smaller image. And so now what we can see is we can see down here the date. This is June 15th of 2021 in the North Pacific. Now, our next Slido question is, why can't we see the blob? So any thoughts on that? So Alaska. Why can't, this is just an area of anomalously high SST and not a physical bump. So only temperature sensors can see the blob. That's true, but we're looking at SST. We're looking at sea surface temperature. So, whoops, getting ahead of ourselves. Where is it? Yeah. So we're looking at sea surface temperature here. So why can't we see the blob? Because this is temperature we're looking at. Because it's intermittent. Yes, okay, 2 people got it. Well, that's a good, the date specified was an average temperature for that time of year. Yes, anyways, it's because we need an anomaly map to see it. Basically what we're looking at here is because it's that anomaly, it's too small of a signal to be seen on just the, this temperature map. So we want to look at the anomaly. So let's go to the, remember I said everything on the URL is changeable. Instead of looking at the PNG, let's go to the graph interface. And to do that, I just changed PNG to graph. And now here, I'll make this a little smaller. This is the make a graph interface for this data set. Now, for this data set, the reason I picked this one is because it also has an anomaly product. So I'm going to change the color that we're seeing from sea surface temperature to sea surface temperature anomaly. And then I'm going to hit redraw the graph. Hey, look at that. You see all this really warm water here. And you can see the range here. Basically, this is all temperature anomalies greater than 2. This red value. So basically this area here is what we would classify as a marine heat wave. And you can see there's a little bit of one up in the Alaska region now. So that's why you have to look at the anomaly. Now, remember before I was mentioning a Hofmeiler, and a Hofmeiler can show you both sort of time and space. So if we're curious, I mean, we can see there's this really large area here. And, you know, if we want to know, well, how long has it been there? We could go back and we can go to different time periods. So if you go to the time dimension here, if you just hit this negative sign, it'll take you back 1 time increment. So that's May. And that's April. And you can see it's getting smaller. It's kind of moving westward. That's in February. This thing's been around a long time. Our region in Alaska has disappeared now, and we go back to February. January, you can see it's a lot further south. It's down by Hawaii in January. So you can keep doing this, but you know, there's a lot of, this gets a little repetitious after a while. And so a better way to sort of look at time and space scales at the same time is to use what I call the Hofmeiler. And so what we're going to do for that is if we go back to, we're going to take a slice through sort of the center of where the anomaly is. So this looks like it's about 40 degrees latitude. So what we want to do is we're going to look at data along this line here. So that's going to be on the x-axis, and then on the y-axis we're going to have time. So if you can sort of think of taking a slice through here and then looking at how that changes with time. So we're going to change the y-axis over here to time, and then it automatically comes up with, it doesn't know what latitude we want, so it automatically picks the most southern one. That's not the one we want. We're going to want the latitude to be at 40 degrees, because that's sort of the center of that, the warm water, as we indicated. And let's make this for a longer time period. So let's look at, like, say, the last, well, let's look at the last, say, 6 years, and hit redraw the graph. This might take a little bit of time because it's accessing a bunch of data, but it shouldn't take that long. And there it is. So we don't have any data over here because this is over land. But what you can see is you can see how there were times actually when the blob actually disappeared, when we had colder waters here in 2016 and the beginning of 2017. But actually, for most of the last 5 years, we've had really warm water in the Pacific Ocean. And you can see the movement of it. So keep in mind, this is the West Coast of the United States. So there are times when, like in 2015 and 2016, when all that warm water was really up against the coast. And that's when we saw a lot of impacts on the coastal areas. Then there were times when it sort of moved offshore, like in this time period here, all the warm water is really sort of more in the middle of the ocean, but not up against the coast. And now you can see, like now it's really back up against the coast. It's also in the middle of the ocean. But this is a way that kind of you can see the spatial and the temporal variations at the same time. And then, so this is great. So you're like, well, gosh, I want to do more with this data. I want to download it. I want to kind of play with it in R or MATLAB or whatever you use to process data. So to go to data, to get this data, you can go to the data access form. And this automatically brings across the constraints you had before. So this brings across those 6 years of data we were looking at. Because we're looking at a Hofmeiler, it just has this range. It just has one latitude. So you probably want to change that. You can do that by entering in the values here or by just changing the scroll bars down at the bottom. And then, as I mentioned before, there's different variables in here. So we were just looking at sea surface temperature. So sea surface temperature is checked, but you might, the sea surface temperature anomaly, but you might also want to bring across the sea surface temperature itself. And then you would just select which kind of file type you would want. For satellite data, the NetCDF is the most efficient way to really get this data. So if you choose a NetCDF file, and then just submit it, and then it'll just download it. This is kind of a big of a chunk of data, so it might take a little while, but it'll download that to your download file. It is almost 10:45 now, and I know we were going to take a short 10-minute break at 10:45. Before that, maybe we can go back and see if there's any questions in Slido? Yes, we do have one question. Would it depend on which data type we want to use for Python? I guess I'm not sure what that question means. Does whoever asked that question, can you unmute yourself and expand upon that question?
Would it matter what, like the NetCDF or the CSV file?
I'm sorry, I couldn't hear you.
Does it matter which one we use, the NetCDF or the CSV, for when we use Python?
Oh, for if you want to bring the data into Python?
Yeah.
Yeah, I think you would probably want it to bring that in as a NetCDF file.
Okay.
Are there any other questions? Do we want to take a 10-minute break? Yes? No? Should I keep on going?
I'll keep on going.
All right, I'll keep on going then. Okay, let me get back to, so actually this is just another Hofmeiler that I made of the sea surface temperature anomaly. So are there any questions about anything that I just did? I mean, I know I kind of went over that quickly. Did that make sense? Was there something that wasn't clear? Anything you want me to go over again? Okay. One of the other things I want to show you about Erdapp that's really quite cool is that, so this is the image, this is the file we were looking at before. Actually, let's go back in time a little bit. Well, actually, if we go back to, was January of 2014. Yeah, so this was kind of the original blob. So this is January of 2014. You can see it's very very well-defined blob, which is how it got its name. And let's just go down a little bit. So we were talking about the URL and how to generate the URL. And, you know, it might seem like, yeah, you know, I'm never going to be able to figure that out. And how exactly do you do that? Whoops. Sorry, where did my, there we go. From either the make a graph page or the data access point or the data access page, there's always this function down here that says view the URL. So for this image here, which we're looking at in the graph, so because of that, the URL here is graph. But if, say, you wanted to make a PNG of this, I've showed you, you can just turn this into a PNG. But also down here, it also shows you the URL. I mean, it's going to show you up here at the top of your screen, but it's also down here. It gives you how to get the URL. So this is important. Like, say, if you want to bring it into MATLAB or Python, it will define the URL for you, so you don't have to sort of put that together on your own. But let's go back to looking at just the PNG file for this. And one of the things that Erdapp can do, which is very powerful, is, so in this case, we're looking at January of 2014. And that's indicated by the date in this part, in the date part of the URL. But one of the things you can do is you can, instead of actually specifying the date, I've taken that away, you can say last. And what that will give is that will return the most recent data. So this is really useful if there's your favorite part of the ocean that you're interested in monitoring. If you put in this last, it will always show you the most recent data. So, if you come back to it 3 months later, it will update it. So if I hit return now, it should give us the most recent data rather than the data from 2014. So you can see the image has changed, and now it's data from June of 2021. It can also do last math. So last -3 should be from 3 months ago. Of course, it doesn't work. Didn't that work? It's still showing the June. I know there is a way to do last math. That's the fun with live demos. Okay, let's see. What else did I want to show you? Are there any questions? Can Erdapp interface provide data over land as well? Yes, it can. I mean, so that's a good question. So basically, if we go back to Erdapp, is going to provide you data anywhere there is, any place there's data. For this data set, sea surface temperature anomaly, there is no data over the land, and there is a land mask, and so which you can take off. So let's go back to the graphing interface, and I can show you that. So you can see here it says draw the land mask. So you can do it under, over. Because there are some data sets, like some of the ocean color data sets, that have have data in like lakes, and if the land mask is over it, it might actually obscure some of that data sets. So, and I'm trying to think if there's any of the data sets that we have that might. Well, actually, I'll show you. We'll go back to Erdapp. And if you just go to the main Erdapp, there is this text search here. So I'm going to look now for topo because we have a topography data set. So this is global. Oh, the other thing I should mention to you is, so here we're looking at, we did a search and it's bringing up topographical data sets. And you can see for a lot of these, the title has the same name, but then afterwards there's a long 0360 and one doesn't have that. You might be like, what is that about? Anybody who works in the Pacific Ocean or also in a little bit in the Atlantic Ocean, the date line and it's a real problem because, you know, if you want to cross the date line, if your data set is using negative 180 to 180, there's a discrepancy there, right? And so often data sets will have longitude of 0 to 360, which is really useful if you're in the Pacific because then it will easily cross the date line. ArcGIS doesn't like data sets that way. So basically a lot of our data sets, not all of them, but for most of them, we offer them in the longitude of 0 to 360, which is indicated here by 0 to 360. Or if it doesn't say it, then it's in negative 180 to 180. So that's something to keep in mind. So we will pick, and you can see here, we'll go 0 to 360 since we're looking at the Pacific Ocean. So what this data set is showing is it's showing the topography, and it's negative when it's in the oceans, and then it's positive on land. And so you can see here that there's continuous data set here. So basically it's over land and over the ocean. And so in this case, if we draw the land mask over the data set, now we're not going to see the continents anymore. Continents are gone because our land mask is over it. No other questions? The other thing that you can do, so I was showing you, if you go back to the main Erdapp, so this is the Erdapp at the Environmental Research Division, Southwest Fisheries Science Center. And you can see actually we have over 2,000 data sets. So here's the search where you can search for, I don't know, anything you want. Like we could put in rain. We have some precipitation data sets. You can see the search is not perfect. It also pulls up the Noaa ship Rainier because rain is in there. But there's also a way that you can, remember I said there's like over 85 different Erdapps. So if you're searching for something and you're not sure if it's on any Erdapp anywhere, you can search for all Erdapps by going to erdapp.com, very easy to remember. And first is testing the connections. So it looked like 56 Erdapps that it was pulling up. There's more Erdapps out there. I'm not sure why it doesn't necessarily ping them all. But here you can put in, you can search for a data set across any of these Erdapps. So actually let's do the topo again, the one we were just looking at. So we'll put in topo and see what we get. And so here it's coming up, Great Lakes bathymetry, and this is giving you the data set name here, and then underneath it gives you the name of the Erdapp where that data set is. It's giving you an institution. I guess for a lot of these data sets they didn't indicate. A lot of Great Lakes ones are coming up. This is the Noaa Great Lakes Lab. And then I think at the top it tells you how many. Yeah, so it found 9,000 data sets. So in this case, you might want to throw in some other search terms to get down your data sets. But the point is, there's a lot of data out there, and that sort of brings up, there's a sort of, like with any decision you make, there's pros and cons. So for our data set, our Erdapp, where we have 2,000 data sets, we realize that sometimes that can be a con because it can be overwhelming. Like there's too much data. I don't, how can I find what I want? Polar Watch, which is a newer Coast Watch node, we have a much more tightly curated data set list. So we've kind of handpicked ones that we really think will be of most interest. And so there's only like 100 or 150 data sets on there. And so that sometimes that makes it easier to have, you know, less choice. One of the things, actually, let me go back to the PowerPoint because there were a couple of things that I wanted to bring up in there. So this is where we left off in here. Let's go back. We have another Slido question. How are satellite SST measurements made? Polls. So any thoughts about this? How our SST measurements are made? Or satellite measurements? Well, the answer is all of the above. That's the really kind of cool thing about sea surface temperature measurements, is that because there's this whole breadth of ways we can measure it in the IR, which is how kind of most traditionally the measurements have been made, but we can also measure it in the microwave. And the benefit of measuring it in the microwave is that we can get data through clouds. And then we can also we can make measurements on polar orbiting satellites and on geostationary satellites. But it looks like you all got that answer, so great. Let me go back to the PowerPoint.
Cara, before you go back real quick, looks like there are some questions in the Slido.
Oh, awesome, thank you. Okay. Is there a more efficient way to create SST charts for hurricanes rather than using the RDA Ucar site? Well, I'm not familiar with using the RDA Ucar site, but for me, I mean, I'm obviously biased, but I think Erdapp is one of the easiest ways to make charts. And the thing, I mean, so you can make them quick and easily with Erdapp. You know, I showed you how you can use the last function to have it constantly update. If the data set that you're looking for is in fact on Erdapp. As I said, without knowing how the RDA Ucar site works or the specific data set you're working with, I'm not sure how else to address that question. If whoever asked that wants to follow up on that, I'd be happy to respond more about that. Is there some way we can see the spatial resolution of the data set we're looking at? That's a really good question. So we have tried to go back to Erdapp. We try to, on the data sets, mention the resolution in the data set title. So this one tells you here that it's 5 kilometer. It doesn't always, and we have 2,000 data sets, and some of them we get from other places. And so unfortunately, our data sets naming is not always consistently done, but we try to have it in there. The other thing that you can do, and this is actually what I was going to get to back in the PowerPoint, is if you go to the Coast Watch website, and I'm just going to do Coast Watch ERD. We have, oops, that's not what I wanted to do. It's just Coast Watch PFEG. .gov. So recognizing that it can be really difficult to, plog through 2,000 data sets and figure out which one is the best. What we've done at Coast Watch, what Dale has done, Dale Robinson is the node manager for the West Coast node of Coast Watch, is he has come up with a data catalog. And so if you go to the data catalog for the West Coast node, and keep in mind that even though we're called the West Coast node, most of the satellite data sets that we have on the West Coast node of Coast Watch are global resolution. And so what Dale has done is he's put together a nice catalog where you can pick your parameter, SST or ocean color, wind salinity or sea level. And we sort of have this curated list. So it'll, so for example, if we go to SST, and this gives you, here you can have the resolution, it shows you 0.05 or 5 kilometer. And it tells you the range of it. It tells you whether it's global or not. But these are sort of like the ones that we, the sort of top users, the one that we sort of recommend the most. And so we do have some regional ones. SST, the highest resolution you can, VIIRS has a 750 meter product. And so we have that for the Northwest and California. And there's also a 1 kilometer that we have for MODIS. So you can see these down here. So that's often a good place to go, is to go to these catalogs. But yeah, it's something we get a lot, and we realize that, you know, it would be better to have an easier way of sort of honing down and finding those high resolution data sets that a lot of people are interested in. Let's see. Is there a limit to the size of the body of water to get surface temperatures? For example, I'm in Minnesota and we have several large lakes. 60 to 40 miles. So there is, I mean, and off the top of my head, I don't know how small you can go with lakes. There's other issues in terms of getting the temperature of lakes. Part of it is that the sea surface temperature algorithms are designed for for ocean, and there are differences looking at lake temperatures. There's the Great Lakes node, which serves up data for the Great Lakes, the 5 Great Lakes. I don't know how much data they have, if they have any actually in the other smaller lakes. That's actually a good question. There's the Great Lakes node is actually doing a training tomorrow. If you're interested in more data from the Great Lakes, ping me offline, and I can get you the information. Go to the Great Lakes satellite class that's happening tomorrow from, I think it's 1 to 4 East Coast time. Any other questions? Okay, I was going to go back to the PowerPoint. We did how satellite measurements are made. Everybody knew that. That's great. Yeah, so I just wanted to give you some additional resources. So we started off talking about the Blob, or the marine heat waves, and there's a whole page dedicated to this. It's kind of a long URL, but it's listed here. You should have access to this PowerPoint, so that link is here. This explains to you what a marine heat wave is, and shows you the latest conditions and talks about it, and there's also some references in there as well. So I suggest you check this out if you're more interested, if you want more information about marine heat waves. The homework assignment was for you to look at the first 4 chapters of the Erdapp tutorial. There was some other chapters in there as well, and this is just kind of a good resource that we put together for people, which basically walks you through Erdapp and understanding Erdapp and kind of getting people started on Erdapp. Another online tutorial we have, as I mentioned, we've done we work a lot. A lot of our users who come to our satellite classes use R. It's used heavily in Noaa because it's free. So we've put together a bunch of scripts and using a package called R Erdapp Extracto, which is actually also developed here at my lab, which shows you how to do sort of common things that our fisheries users want to do with data. So if you're an R user, I highly recommend that you check out this R and Erdapp tutorial online. And then lastly, I wanted to mention the West Coast node of Coastwatch, which I just showed you. We have that data catalog, which is a really nice way to sort of make some suggestions of data sets to kind of get you started in the right place if you're interested in satellite data. So that's about all that I have. Oh yeah, I had one more slide of question. If the next and last session that we're doing is August 11th, I will be doing that again, and that's going to be on sea ice. I'll be talking about accessing data through PolarWatch and also some of the other sea ice data providers that are out there. So I'll go to Slido and see who is interested in sea ice. Great, everyone's going to go. Cool. I see there's another question. We have a tutorial for Python, if one does not know R. You know, we are working on developing a Python tutorial. I myself work on R, and some of our other colleagues like Dale and Jen and Melanie are developing the Python one. Dale, are you online? Dale is not online. Yeah, I think Dale had to be on a different call. Yeah, I think we have it. You know, actually, so if whoever asked that question, or actually if anyone is interested in Python, well, I'm pretty sure we do have something. I can't get the link off the top of my head, but I will get that information, and I will put it. I will put that information in the course information folder. So I will follow up on that after. Several of the links for the example graphs in the online tutorial don't work for me. I get an error 404. Well, that's problematic. Well, yeah, whoever posted that, I would be really curious. I'd like to figure out what those problems were. If you could email me the issues that you got, just cara.wilson@noaa.gov. That would be great, and I can figure out what the issue is there. Okay, so it was Kyle. Kyle wants Python. Are there any other questions? Very useful, informative lecture. Thank you. So no more questions? So the other thing to mention, I guess, is that as I mentioned, the Great Lakes node is doing a satellite course tomorrow, a 4-hour course. This is something that we as in Coast Watch offer a couple times a year, usually a 3 or 4 day course on using satellite data, where we go into in a lot more detail about how to access these data sets. When we do those courses, we always ask participants what software they're using. And so, that's why we've developed a lot of the stuff for R, why we have it going for Python, because we teach those classes with the idea that we want to show you how to use satellite data in the software that you're used to. Like Kyle said, he's like, I don't do R, I do Python. So we've developed, and that's why we're developing the Python ones. As I said, I will get that information about the Python tutorial that we do have written up, because we do have something, but that's we started that more recently than we started R. We've been doing stuff for R for a long time. But anyways, there's also, if you're interested in the satellite courses, there's if you go to the Coast Watch, the main Coast Watch page, I think there's an area where you can sign up to get notifications about any upcoming classes.
Okay.
All right. Well, if there's no more questions, I guess we'll end early.
Yeah, Cara, thank you so much for the session.
Sure.
For those who are in the session, can you go to the lower right corner? There is a reactions. Let's give Cara a round of applause for her lecture today. Thank you a lot. And this is the third one. We are the first one on August 11th. And I have to say that the working group put a lot of efforts on this, and all the lectures are recorded, so you can always go to the MS website to look at them. And we hope this will be helpful for whatever you are studying or advance your research career. Yeah, thank you.
Great. Thanks.
Bye-bye then.
Okay. Bye, everyone.
Bye.